Hi friends, welcome back to our YouTube channel. Today we have to discuss about Java program for finding the roots of a quadratic equation. In Java language, first I am taking import statement. Import java.util.scanner. So by using this statement, we have to import the scanner class available in util package. Scanner class is used for reading the input from the keyboard. Next, we have to create one class. Class name is roots. Next, we can go for the main method. Public static void main string arguments. So this is the main method. Every Java program execution starts with main function. Next, we have to create the object for scanner class. Scanner SC is equal to new scanner system dot in. Now we already know that the quadratic equation is in the form of ax square plus bx plus c is equal to 0. Now we have to read a, b, c values from the keyboard. So system dot out dot println, enter a value. Double a is equal to sc dot next double. So by using this statement, so a value is read from the keyboard. Whatever the value that we are given from the keyboard, that can be taken as string. That string data type is converted into double data type. We have to use next double method. Okay. By using this method, we are converting the string data type value into double data type value. After converting, that value can be assigned to variable a. Next, in the same way, system dot out dot println, enter b value. B value is also read from the keyboard. So double b is equal to sc dot next double. So whatever the value entered from the keyboard, that can be taken as a string. So that string data type value is converted into double data type value by using next double. This method is available in scanner class. After converting, whatever the value is there, that value can be assigned to the variable b. Next, in the same way, c value is also read from the keyboard. System dot out dot println, enter c value. double C is equal to SC dot next double. Next, once we are reading the A, B, C values, then we have to find out the determinant value, discriminant value. So, double D is equal to B square into B square minus 4AC. B into B minus 4 into A into C. So, B square minus 4AC. So, after calculating the D value, we have to check whether D value is equal to 0 or less than 0 or greater than 0. Suppose if D value equal to 0, system dot out dot println. If the D value is equal to 0, we can say that roots are real and equal. Roots are real and equal. Next, root 1 is equal to root 2 is equal to minus B by 2 into A, minus B by 2 into A. So, this is the root 1 value and the root 2 value when D value is equal to 0. Now, we have to print that values. So, system dot out dot println. I am taking format here. I am taking format here. Root 1 is equal to percentage 0.2f double quotes n comma root 1. So here root 1 value is printed. Suppose if the value is a floating point number, after the decimal point we are consider only 2 digits. For that purpose I am using percentage 0.2f. Next, in the same way we have to print root 2 value. System dot out dot format root 2 is equal to percentage 0.2f double quotes n comma root 2. So, if D value is equal to 0, we have to print both root 1 value and root 2 value. Next, here we have to declare double root 1 comma root 2 semicolon. Next, suppose if D value equal to 0, condition false, then again we can go for else if D value greater than 0, then we have to say that roots are real and distinct. println roots are real and distinct when d value greater than 0. Next, here root 1 is equal to minus b plus math dot square root of d divided by 2 into a. So this is the root 1 value, minus b plus math dot square root of d divided by 2a. Here we have to put open parenthesis and close parenthesis for minus b plus math dot square root of d by 2 into a. In the same way, root 2 is equal to minus b plus math dot square root of d by 2 into a, semicolon. Next, we have to print root 1 and root 2 value. System dot out dot println I have to use format here as mentioned above. Format root 1 is equal to percentage point 2f root 1. Next, system dot out dot println root 2 is equal to percentage point 2f double quotes n comma root 2. So in this way both values are printed. Next, another case is else. Else is nothing but it automatically the condition is d less than 0. D less than 0. So system dot out dot println roots are complex and real. Complex, roots are complex. Next, here whenever the roots d value is less than 0, roots are complex and imaginary. At that time, complex number contains both real part and imaginary part. So I am taking real is equal to minus b divided by 2 into a. So this is the real part. Next, imaginary part is img is equal to minus b plus math dot square root of minus d. So this is the formula for imaginary part. Minus b plus math dot square root of math dot square root of minus d divided by 2 into a. Real part is minus b by 2 into a. Imaginary part is math dot square root of minus d divided by 2 into a. Okay. Now we have to print both the roots. So system dot out dot println. Here I am taking format root 1 is equal to both real part and imaginary part. So I am taking percentage point 2f plus percentage point 2f. Here for first percentage point 2f, this is the real part, comma, for the second percentage point 2f, this is the imaginary part. Next, in the same way, system dot out dot format root 2 is equal to percentage point 2f minus, so here also I am writing I because complex number is in the form of a plus ib. So I percentage point 2f double quotes and comma real comma imaginary. So this is the two roots. Here I am declaring real, double real. Here also double imaginary. Data type is double. This is the main method close. Now we have to save the program. So here roots dot java. So I am replacing that is already existing. Now we have to run the program. So cls. So for compiling the program, we have to use javac filename dot java. File name is roots dot java. So the program is successfully compiled. Now we have to run the program. For running the program, we have to use java roots. It is successfully running. Enter a value. A value is 2. Enter b value. B value is 4. Enter c value. C value is 1. So roots are real and distinct. Root 1 value is equal to minus 0.29 and root 2 value is minus 1.71. Next, again we have to run the program for getting Another case, Java roots, enter a value. Now a value I am given 2, enter b value I am giving 4, enter c value I am giving 2. So then here roots are real and equal. Root 1 is equal to minus 1.00 and root 2 is equal to minus 1.00. So both root 1 and root 2 are equal if d value equal to 0. Suppose if d value is greater than 0, roots are real and distinct. Root 1 is equal to minus 0.29 and root 2 is equal to minus 1.71. Next, I am running the program Java roots. So now enter a value. So a value I am given is 1 and b value is 2 and c value is 4. So then roots are complex and imaginary. Then what is we are getting? Root 1 is equal to minus 1.00 plus I into 1.73. Root 2 is equal to minus 1.00 minus I into 1.73. So the first output is if d value is greater than 0. The second output is d value equal to 0. The third output is d value is less than 0. In this way, we have to find out the roots of a quadratic equation program. So thank you one and all for watching this video. If you like this video, please click on the like button and click on the bell icon to get the future updates in my YouTube channel. After subscribing my YouTube channel, DIVVELA Srinivasa. Thank you one and all for watching this